We start with the idea that x double prime equals a. Now the prime indicates derivative with respect to a variable t, which we interpret as clock time or time, so that x is position function. So that x double prime equals a really means second derivative of x with respect to t equals a. And if you know a little bit of physics, you are aware that the second derivative of a position function with respect to time is the acceleration. We also know from physics that net force equals mass times acceleration, so that net force is then mass times the second derivative of a position function. Now we come to the case of a pendulum. If we have a pendulum, if the pendulum is pulled back from equilibrium, it experiences a force that pulls it back in the direction toward equilibrium. So if x is your displacement from equilibrium, then the force exerted is in the direction back toward equilibrium, which would be the negative direction. And this number k here, this constant k, is what you call the force constant. If you know the position, you multiply by k and take the negative, and that gives you the net force. This leads us then to the equation mass times acceleration is equal to negative kx, where m is the mass of the pendulum. And from what we've seen here, the acceleration is the second derivative with respect to clock time of the position function, so that our equation becomes mx double prime equals negative kx. Now, the question is, can we solve this problem? Which means, can we find a function x of t such that x double prime of t equals negative k over m times x. Now we're not going to try to solve that now, but we'll see that very shortly. We'll see at least the nature of some solution functions.